Welcome to the Crazy Hat Chemist. Here we go. This is the last video on scientific measurements. So let's get moving. Bam! This is the metric system and the international system of units, aka System International. So here we go. So advantages of the metric system for scientists are the following. 1. The majority of countries throughout the world use it. Number 2. The same base units are used with common prefixes. Essential. Number 3, it's based on powers of 10 and using a decimal system, and that makes the math really easy. You're just moving the decimal place to the right or to the left, any certain number of places. So the metric system uses length, mass, and volume, whereas the metric-based system for scientists is the international system of units, and that's all scientific quantities for all scientists. Slight difference between the two. Okay, so let's move on to this. The International System of Units is the fundamental measurement of 7 basic units, and everything can be measured with these. These are called the SI base units. So, here's the measurement property, its unit, and its abbreviation. So, mass is the kilogram, and that is the unit is the kilogram, and the abbreviation is kg. Then we have length, that is the meter, and that's a lowercase m. Then we have time, that's the second, and that's the lowercase s for second. And then we have electric current, and that's ampere, and that is the capital A, like the scarlet letter. The temperature is Kelvin, and that's a capital K. And the amount of substance is the mole, and that's designated, or the abbreviation is MOL. Not very shortened, but it is. Then there's luminous intensity, and that's the candela, and that's a lowercase c and a d. So those are our 7. Volume is not an SI base unit, but it is derived by 1. Which one do you think it is derived from? It is derived from length. That is correct. Okay? There are other derived units of velocity, area, force, frequency, energy. They're all derived from these basic 7 units here. Okay? So, maybe you can look at those and see how they are derived. It's very interesting. Okay, so here are some of them, the common prefixes here. So you see kilo for the kilo in the K, that means 1,000, and that's times 10 to the 3. Hecto is 100, and that's times 10 to the 2. Deca, DA, is 10, and that's times 10 to the 1. Then there's nothing for times 10 to the 0. There's deci, and that's moving the decimal over in the opposite direction, and that's smaller, and that's times 10 to the negative 1. There's centi, that's 0.01, that's in the hundredths place, and that's times 10 to the negative 2. There's milli in the thousandths place, times 10 to the negative 3. Micro, nano, pico, hopefully you're familiar with some of those. This system expands in both directions on the top and on the bottom as well, so don't forget about that part. Okay? You should be able to do conversions between any of these. And here's just 2 examples that are really simple here. We're going to convert 0.052 liters into cubic centimeters. And this is all done by unit conversions, which we're going to be covering in another unit, but your chemistry professor or teacher might have you do some of these now. So this is why I've included it. So here's what I'm starting off with, and I want to eventually go to cubic centimeters. So here's my first unit conversion, and that is liters to milliliters. 1 liter equals 1,000 milliliters. Okay? So now the liters portion cancels out, and I'm left with milliliters. Then I want to convert from milliliters into cubic centimeters. And 1 milliliter is equal to 1 centimeter cubed, which is cubic centimeters. And this is what I get, 52 cubic centimeters or 52 cc's. And maybe if you've had like an injection at the doctor's office, like a vaccine or something like that, that's typically in cc's on the syringe. Okay, here's another example. We're going to convert 4,540 milligrams into kilograms. So again, here's the starting number, 4540 milligrams, and we're going to go from milligrams into grams. That is the unit conversion. Okay, and then we're going to, so this, if we do this multiplication, that is the 4,440 times 1 divided by 1,000, that would give me grams in those milligrams. But I don't want grams, I want kilograms. So I need to go from grams into kilograms, and here's going from grams into kilograms. And then I get this number right here, which is 4.54 times 10 to the negative 3 kilograms, or 454 kilograms. I hope you notice that on all of these, in which we will discuss later when we do unit conversions, all of these unit conversions that I've done here have an infinite number of significant figures, and I've maintained the number of significant figures that are in the original number. So, for example, 1 in 1 liter, when it's equal to 1,000 milliliters, has an infinite number of significant figures in the 1 and the 1,000. The 1 milliliter and the 1 cubic centimeter also have an infinite number of significant figures. The 1 kilogram and 1,000 grams has an infinite number of significant figures. 1 gram and 1,000 milligrams has an infinite number of significant figures. Okay? These are not measured values. These are equivalent unit conversions. That's why there's an infinite number of significant figures. That was our last video, and I received many hats from my students. This is from Jordan and Wyatt, and root beer is my favorite soft drink of choice. So, give me a thumbs up, subscribe to my channel, and drink some root beer. Have a good day.